Okay, so we're doing problem number 1 from SHW 33 that says we have a fish that's hung on a spring scale, and the fish has a mass of 10 kilograms and stretches the spring by 8 centimeters and asks us what the spring constant is. So we're dealing with two forces, gravitational force and spring force. So I drew a free body diagram. I defined my directions. It's an equilibrium because it's just hanging there. So the acceleration is 0. Hence, Newton's second law says sum of the forces is ma is 0. And so I applied Newton's second law to my free body diagram. And applying Newton's second law, I ended up with force spring is equal to the force of gravity. Probably students would have just started at the beginning and said, well, force of spring must be force of gravity. But it's good to have an understanding of why force of spring is force of gravity, because you could have a different situation, like it's sitting on the ground and you have a spring that stretches this much and ask what the force normal is, and you'd have to use Newton's second law to combine the three forces. So now, using my equations for force spring and force of gravity, I have K delta X is equal to mg, and I'm just solving for K, so K is equal to mg over delta X is equal to 10.0 kilograms times 9.80 meters per second squared divided by, and of course the standard unit, what's the standard unit for length?
Meters.
Meters. So I need to convert that centimeters into meters.
So it's going to be 0.08.
00, because we have those sig figs.
Oh, okay.
And then we just pop that in the old calculator. So 98 divided by 0.08.
1225.
Okay, so 1225 newtons per meter. Now, we only have 3 significant digits. So the correct answer would be, do you remember how to round?
1220.
Yes, the correct answer would be 1220. People who didn't learn scientific rounding would have said 1230. Now, for solving part B, we're going to use all the digits. Even though to correct significant digits, all we have is 1220, you don't throw away information.
Okay.
So for part B, what mass will result in stretching only 5.5 centimeters?
So would we take that same equation and just now, except we're solving for m?
Yep,
Okay.
That's exactly right. We take exactly the same equation we worked out relating the forces.
Yeah.
And we just solve for m. So we have m is equal to K delta X over G. Use our K to all the digits we had before.
1225. Okay.
And we're going to end up with 55% of 10 kilograms. So I'm going to go with, or excuse me, not 55%. 5.5 over 8 is not 55%. Yeah, just go ahead and calculate. I was thinking that it stretched 6.875. And we only have 3 sig figs. So the correct answer would be 6.88 kilograms.
Okay. That makes sense, yeah.
Okay, there is a part C that I didn't see on yours.
Oh.
That is how far apart are the half kilogram marks on the scale.
Oh, I do. I made it number 2 on the
okay.
scale. Okay.
So put that in here. Good morning,
Good
Jordan.
morning. I have class in that classroom, but it's locked right now.
You on in?
Yeah.
Problem 13 also didn't have the right answer on it.
Nobody brought up that issue to me.
They were probably like, wow, he really failed.
That's nifty.
Either that or I really failed. It's one of the two.
Yeah, nobody. Which one was that one over? What was the question?
The one with the fur. I did the calculation with 5 centimeters of fur instead of 3 centimeters of fur.
Yes.
One person did talk to me about that
one.
fur. They're like, they're asking me, oh, what did they?
We was trying to figure out if the beta and the alpha were like. So.
No, that's a different one.
Oh, oops.
That one was correct. It was done incorrectly on the supplemental homework site.
Oh.
The fur one. I had one person ask me a question about that, but I think the way it was asked to me, it was more like trying to see if it was like if they were doing the right thing.
Trying to get you to confirm.
Yeah. And so I didn't. I was like, I can't say that. But so that's why I didn't look too hard into it.
Yeah. So yeah, I'm chagrined.
But with the number 12 one,
Yeah.
I literally I walked back in the room. I was like, okay. Somebody had their hand raised. They were about trying to get my attention as I was walking out the room. I'm like, okay, wait, I'll wait. I walked back in the room. I was like, number 12, and everybody's like, thank you. And one person's like, I knew it.
Okay, good that's going to be on the recording. So for part C.
Whoops.
Okay, you haven't gotten to part C yet.
I am.
Faster than I thought. Thank you.
All right.
That is really nifty, though.
I love it.
Here.
Okay, so for part C, it asks for the separation between the half kilogram marks.
Mhm.
So what would your method be for doing that?
I am taking a measurement and I don't know. How far apart are the half on the scale? A kilogram is wait, okay, so 1 kilogram or 1,000 kilograms. No, 1,000 grams are equal to 1 kilogram. And if we took that, how far apart are the half kilogram marks?
Mhm.
So then wouldn't that be equal to 500 grams?
Half kilogram is 500 grams. That's correct.
Okay. Is that the method that we would use to... But
Well-
then we're dealing with a scale. I don't know. That's how I would go about trying to... But then...
Okay, so show me your work.
1,000 grams. 1,000
Because
grams.
we don't have a distance marked yet or calculated yet. Right. What we're looking at is we have a scale. So the scale has a spring and a hook, and then it has a body that goes around this with a marker. And the position of, actually, I should have made this go lower. And as this marker moves, you have different things. So you have, 0.5, 1, 1.5, etc. is marked on there.
Mm-hmm.
And that's telling you how much mass in kilograms, assuming that G, right, that it's calibrated for the spring constant in G, because the
Okay.
scale actually reads a force. And then if you know what G is, you can translate from force to
Okay.
mass. So it has those marks, and it's asking us what the spacing needs to be. So our answer needs to be in centimeters.
So would we take that now? And since we know that force is equal to mass, or force gravity is equal to mass times gravity,
Mhm.
if this is the force, we take it and divide it by. No, this is the mass. Well, but then since it's
because
hanging,
you have to run the class, you have class in 3 minutes,
yeah,
right?
I do.
So I'm going to run to the quick of this.
Okay.
There is a quicker way and a longer way of doing it. They both give you the same answer and they're both perfectly correct. The way that I expected you to answer here was to say, well, let us take this equation again and just solve it for delta x.
Oh.
And then put in 1/2 kilogram to see how much it stretches for a 1/2 kilogram.
Oh.
But there's a quicker way. The quicker way is we know that we have a linear relationship. Force is equal to K delta X. So the force changes linearly with delta X.
Yes.
So I can just say force 2 over force 1 equals K delta X 2 over K delta X1. I can cancel the K's. And then I will just put in my force 2 is G times mass 2, which is 1/2 kilogram. Right, because it says for a 1/2 kilogram.
Right.
Force 1, I'll put in what they gave me, G times 10 kilograms. So my G's are going to cancel.
Okay.
Is equal to delta X2 over delta X1, which was 8.0 centimeters. 8.00 centimeters.
Okay.
Right. So I used the calibration information they gave us. The 10 kilograms gave me 8.00 centimeters. And then the 1/2 here. The reason this is quicker, it looks longer because I'm doing everything so explicitly.
Yes.
But what we see is, hey, all I have to do is take my 8 centimeters divide it by the mass I used then and multiply by the new mass. And so I have 8 divided by 2 is 4. Divided by 10 is 0.4. And so it was a quicker calculation. I could do it in my head just by looking at the original numbers without.
Okay, I see.
I mean, if this was on the test and you didn't have to show your work, I would have just answered and moved on because I could look at the numbers and say, okay, just looking at these numbers here. So if the mass had been 1 kilogram, it would have gone 0.8 centimeters. 1/2 kilogram would be half of that, 0.4 centimeters. Right, so I could have done that real quick in my head.
Okay.
But either way is correct. And of course, with doing all the drawing it out, it was longer the way I did it here.
Right.
This way would have been faster with all the drawing out I did.
Okay. Thank you.
You are welcome.